Okay, good morning. Welcome to
FamilyMath number 291a. Hey.
291. So today we're going to study Archimedean solids with our Zome tool set. And we're kind of not exactly going to do everything they suggest, but we're following chapter 12, I think, in the Zome geometry book. So they define Archimedean solids as solids that are symmetric. What does that mean?
It means if you cut them in half, you'll see the same thing on each side.
Interesting.
And if you cut them down an axis,
okay,
you should see the same thing.
All right. What else? What do you think symmetric means?
Well, that means it's this, if you draw an imaginary line, like around an imaginary equator around it, you'll see the same thing on the top and on the bottom.
Interesting.
Or it could mean that each point on one side corresponds to each point on another side.
Yeah, there's lots of ideas about symmetry. So somehow they're the same on either side. Somehow, not exactly sure. Convex. So Archimedean solids are symmetric. Convex. What does convex mean?
It means no angles in it are bigger than 180.
Interesting. Do you know? What do you think convex means?
Well, it means if you take two random points, you can connect them, and two random points in the shape, you can connect them by drawing a straight line, and that won't pass outside of the shape.
Wow, that's actually a very good definition of convex. Okay. So it just means they don't have any things kind of sticking out on the sides or something like that that are somehow hard to get to or something like that. Okay. They have more than one type of regular polygon. Oh, that's interesting.
So like a cube would not be an Archimedean solid.
Okay.
But what about a rectangular prism? You have different types of rectangles.
Huh.
But that's still a type of polygon.
Yeah, it's a very interesting observation.
But I guess it isn't a regular polygon, so.
Well, more than one type of regular polygon. Okay, and vertices that are equivalent.
What does that mean?
So that means each vertex connects the same number and same type of figures together. So that's actually pretty interesting. But it's hard to see what these are. Although they do quickly give some examples. Explain why the following polyhedra are not Archimedean solids. Okay, so their first example is a pyramid with a square base and four faces that are equilateral triangles. So that's actually a tricky question. Why is a pyramid with a square base and sides that are four equilateral triangles not an Archimedean solid?
Well, it's not symmetric.
But if you cut it down the middle, you get the same shape on each side.
So it does
But
seem
if
to
you
have...
cut it in half, you don't get the same shape.
Yeah, but there are some ways to cut it where they would be the same on both sides. So.
Well, are the vertices, there's the apex of that pyramid is not equivalent to the other four.
Ah, interesting. Why not? So it's because the vertices aren't equivalent on this one.
Because the four base points connect two triangles and one square to each other. And the top point just connects four triangles.
Interesting. Okay. All right. Part B. I'll let you answer this one. The Platonic solid. So, for example, here's a cube. Why is a cube not an Archimedean solid?
Well, they contain only one regular polygon.
Interesting. All right, and then finally, they say the Zome ball is not an Archimedean solid. So I don't know how well that's going to show up on camera, but the Zome ball. What makes the Zome ball not an Archimedean solid?
Well, are the vertices not equivalent again? Well, is it convex?
I think it's convex. I think any points inside of there would be...
Looks like it's convex.
But is it symmetrical? Well, if you slice the line from this top pentagon to the bottom pentagon,
Looks like you get the same figure
Yeah, it's pretty symmetric to me.
Are the vertices equivalent?
Yeah, each one I can see at least connects up 2 rectangles, a triangle, and a pentagon.
So why is it not Archimedean?
Well, because
Well, there are definitely,
well, there's regular polygons on it.
but not
Yeah.
all of the polygons are regular.
Oh.
Because if you maybe can see this rectangle, it's
Yeah.
a rectangle, not a square.
Interesting.
So that's not an Archimedean solid.
Yeah. Now it says, even though they are not classified as Archimedean solids, regular polygon-based prisms and antiprisms, prisms and antiprisms with regular faces also meet the conditions of Archimedean polyhedra, but they are, because there are infinitely many of them, it is traditional not to count them as a separate group. So you made a very interesting observation right at the beginning that prisms meet this definition.
Yeah,
But it's traditional to not count prisms as Archimedean
since
solids.
there's infinitely many.
Yeah, since there's infinitely many. So we're going to make 3 Archimedean solids. We're going to make an icosahedrodecahedron, which is made out of equilateral triangles and pentagons.
Yep.
That's what it sounds like.
Maybe we can make a snub cube, and maybe we can make something else. So this will be a fun little project today.
Okay.
All right,
Alright.
let's go.